Hello, Donica. Welcome. Thanks for joining us today. We're just working on the do now. We'll get started. I don't know how much time is left. A couple seconds. Yeah. All right, guys, so that's the time for the do now, just to let everyone kind of come in from their lunchtime. Again, you have until 11:59 p.m. to submit that to me and turn it in. So yesterday, we were kind of going over scientific notation with negative powers, right? When it was a decimal, right? Really small number. So now we're going to do the opposite of that. We're going to do really big numbers, billions, millions, trillions, with positive powers. So we're going to take notes in our journal, just like we did yesterday. So if you can have that out and ready to go, and then we'll do a couple of examples, some practice problems, and then we'll take our break. We'll do your independent practice, and then we'll wrap up the day with our exit ticket. So that's kind of what we're going to go through in class today. Are there any questions about today? No, we're all ready to go? Okay, great. All right, so let's go ahead and take your journals out, and we'll finish up some notes. No, that's not that one. All right, so let me pull up my document camera, and then let's go to table of contents. Let me pull up my document camera over here. And the camera, hopefully we all can see in a little bit. There it is. My math journal that I keep for your class. Hey, Jasmine, thanks for joining us today. I appreciate that. All right, so table of contents. So it's going to be very similar to what we wrote down yesterday, except now we are going to have positive powers, and we're going to be on page 6 instead of page 5. Oh, thank you, Julio, for reminding Leo. I appreciate that. I thank you so much, sir. I appreciate that. I don't know why there's not that many of you guys. I don't know. Hopefully they come in little by little. Maybe lunch took a while. I don't know. All right, so I'll give you like 15 seconds just to jot that down on your table of contents. Okay, sorry. So let's go ahead and let's get started on our notes. Hey, Madison, thanks for joining us today. I appreciate that. We're just taking some notes down in our journal. So if you can just go ahead and quickly get these down. If not, I will make copies or I'll take pictures and I'll upload them into Schoology at the end of class like I did yesterday. Hopefully you jotted those down. All right, so we're gonna do scientific notation, but with negative powers, okay? So just like yesterday, it is the same type of setup, right? Where it's expressed as a product of two factors, and product number one, or factor number one, is gonna be a number between 1 and 10, and our factor number two is always gonna be to the power 10 of some number, right? It's gonna be, since it's a positive power, it might be 10 squared, 10 cubed, 10 to the fourth power, 10 to the 10th power. I don't know, it just depends on the number that they give us. So any scientific notation, whether it's with a negative power or a positive power, they're always gonna have those two stipulations. Factor one must be between 1 and 10, and factor two must always be a product of 10. All right, and so positive powers, we're gonna have very large numbers. Like I said before, millions, billions, trillions, what does I mean by big numbers, right? Where we have a lot of commas. And so right now we're gonna go from standard form to our scientific notation. And the steps are very similar from yesterday, except they are going to be a different direction, right? Because we're not moving the decimal, we're moving it to another spot. So this one, we'll do step one. Let me move it up just a little bit. So this step one, yesterday we moved the decimal to the left. Today we're gonna move the decimal, I'm sorry, yesterday we moved it to the right, today we're moving it to the left to make, again, that number between 1 and 10. So the example I have here is 72 million, and we're gonna turn this standard form number into scientific notation in just a little bit. I'm just gonna give you a little bit of time to jot down those numbers.
My handwriting has improved more from math class than it has from ELA.
Really? That's interesting. Huh. I'm gonna tell Mrs. Nettles to make you write more in ELA. Did you guys know that it was her birthday today? No?
She didn't tell us anything.
Oh, well, it was her birthday. So maybe you can send her a little message in Schoology or something. Happy birthday. Yeah.
Ma'am, you're only gonna make Alexander write more, right? Not us.
I don't know. That's her class. She'll decide whether she wants Alex to write more or seven blue or all seventh grade. I don't know. We'll see what she decides.
The whole topic of today is to write correctly.
Basically.
I've actually tried practicing writing without looking at the words. It's really
I can't
hard.
do that. Yeah, it is. Your word starts to go down.
Yeah, it starts to get out of the line.
Yeah. You're like,
I'm correct it, but then it goes down again.
Or if you can write with your left hand, like if you're right-handed, can you write with your left hand? Or opposite, if you're left-handed, can you write with your right hand? I can't. My left hand looks like really bad.
My mom is really confused about my hands, because I you know how right-handed and left-handed people, they usually throw and write and eat with like the same hand.
Your dominant hand, yeah.
I write with my left hand and throw with my right hand.
Interesting.
I am more
So,
powerful than you. I eat with both hands.
yeah.
All right, so let's go before we go off on a different tangent because we can. Let's look at this example, right? We have 72 million, right? And we're gonna go into scientific notation. So we're gonna move the decimal to the left to make the number 1 to 10. So we have a whole number, but I don't see a decimal. So where is that decimal? In 72 million. Who knows? Go ahead and give me a vertical hand. Who knows where 72 million is? Where's that decimal? Herman, I saw your hand go up first.
It's to the right of the last 0.
Awesome.
Where's
So right
it?
here, right? Right there.
Yeah.
Awesome. Absolutely. Good. So now we're going to take that decimal, right? And we're going to move it to the left until we can get between a number between 1 and 10. And then that's going to be factor number 1. Okay. So we're going to move it. But if I have it there, that's 72, right? That's still too big. So then I'm going to go in between 7 and 2. So I know 7.2 is going to be factor number 1. I know that because we moved it enough to where that first factor is between 1 and 10, right? That's pretty easy. Very similar to yesterday on that, okay? Any questions on how I got there? No? All right, good. So now step 2, remember step 2 is now, we're just basically gonna count how many times did we move, how many places did we move that decimal? And then we're gonna write it to the power of 10. And who can tell me how many places we moved the decimal? Rolling.
7 times.
Awesome, good job. So I'm gonna just write here underneath that we moved 7 places to the left. So now, Kayla, what would be my power? I know it's power of 10, but what would be my little exponent?
Positive. Positive 6.
How many, no, how many spaces did we move it?
7.
Awesome, there it is. So then the power of 10 would be to the 7th power, because that's how many spaces we jumped it. And then this would be factor number 2. So
Miss,
now we can rewrite, yeah.
Can I step down? My dog's biting the curtains.
Sure.
Oh, my
So now we can write 72 million in standard notation. It is going to be our factor number 1, 7.2 times, because remember it's a product, our power of 10, but raised to the 7th power because we moved the decimal 7 spaces. So then this right here is our scientific notation for 72 million. Easy, right? Any questions? I think I like scientific notation. I think it's a pretty easy topic. Alright.
It's harder to go up in scientific notation than to go down.
Yeah.
Because when I went to Laredo, I got more questions wrong going up than I did.
Oh, wow. Oh, no. Okay, so now we're going to go reverse. So now we're going to go from scientific notation to standard form because we can go both ways, right? They're going to give us the scientific notation, and then they're going to want us to put it into a standard form number, right? With commas and zeros and things like that. So these are going to have positive exponents, right? Like this one was a positive exponent because it was positive 7. That means we're gonna move the decimal that we have to the right to make it a larger number. So this is the example that I have. I have 6.2 times 10 to the 6th power, okay? So that means I'm gonna use a pencil so I can erase later if I need to. So that means 6.2, and I need to move that decimal 6 places to the right. If it's here, there's 1, 2, 3, 4, 5, 6. And wherever there are any gaps, that's where you're gonna just plug in zeros. Okay? So then we can rewrite this 62, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. And now that looks kind of messy. I like to see commas. How would we put commas? Does anyone know how we can put commas for this big number? Julio.
For every 3 zeros, you put a comma, like every 3 digits.
But do I start on the left side? Do I go from here and count 3? Or do I go from the right and count 3?
From the left to the right.
So from here to here.
Yes.
Are you sure?
I forgot, honestly.
All right, so you start at the back and you're gonna count 3. So like you said, 1, 2, 3, comma, 1, 2, 3, comma. So then this number is 6,200,000. So we went from scientific to our standard form, or just, you know, number form, basically. Does anyone have questions on going from either standard to scientific or scientific to standard? We're all good? Okay, I really hope that the notes that I gave you are helpful, especially when we do our quiz, and you can do really good on it. I don't know if you guys know, I'm gonna post it on Schoology maybe later today. There is no online classes on Monday for Labor Day holiday. So we do not have online classes September 7. We are off that day, which is good.
It's already Thursday?
Yeah,
No,
it's Thursday.
Friday. It's Friday.
I call it Friday Junior.
Friday Junior, yeah.
Friday
Seems
Junior.
appropriate.
When is it gonna grow up into its own Thursday?
Tomorrow.
Nice.
It goes up on Fridays. Hey, does anyone need some more time to copy down the notes? No? Okay, if you missed anything, don't worry. I'm gonna take pictures and then I'll upload them into Schoology after your class ends. All right, so on the back, just like we did yesterday, this time I actually have an example that I wrote down. Let me zoom in case you can't see it. No, I think I zoomed in too much. Okay, I think that's really good. Okay, so this is our example. And it says here, the distance from Earth to the sun is about 93 million miles. And then we're gonna write this distance in scientific notation. So if someone asks you, what's the distance from Earth to the sun? Now you know, it's about 93 million miles. Yes, Hanma. Okay, so this one, I'll help you out. Hopefully you guys are already doing down the steps already. And then we'll have some practice problems in just a little bit. Okay, so I'm actually gonna just take 93 million and I'm just gonna write that underneath so we can start working on it. 93 million. It's a lot of zeros. I wish that was in my bank account, but it's not, unfortunately. So now I'm going to take the decimal. Remember, if it's a whole number, the decimal is on the right at the end of the number. And we're just going to move the decimal basically till we get to between 1 and 10. So from here to here, I have 9.3, and that actually fits what I needed to do. So that would be factor number 1, 9.3 times, and I know my power is always going to be 10. Now I just need to count how many spaces. 6, 7. So we moved it 7 times. So there is our 93 billion in standard form, 9.3 times 10 to the 7th power. Any questions? Pretty easy. Anyone
Miss,
have any?
if you know your multiples of 3, you could do this much faster by just like, since there's 3, how do I explain this? You know what I mean? No? All right, the zeros, there's 3 zeros for the hundreds, and then there's 3 zeros for the thousands, and then you could put 6 on for the square, but since you have to add another one, so you could put the 9 to the ones, so it's 7. You get it?
Yes. Yeah.
Yes.
Okay. So 3 plus 3 plus 1. That's basically what you're saying. Okay. Yeah. I mean, yeah, for sure. If that's how you want to see it. If you want to go through the steps and make sure you're absolutely correct, and it's not 1 and 2 or whatever. Yeah, for sure. So let's do 2 examples. So if you have your Go Math pages that I sent, we're going to be on page 34, and you can just write the answers on that. If not, I'm going to put them here on my document camera so you can check them out. There they are. Woo. All right. Number 5. Oh my God.
Miss, what page did you say again?
34. It's going to be page 34. I'm sorry. All right, so these are for you to try on your own. Go ahead and convert them to scientific notation, and I'll give you, I don't know, 2 minutes. I don't think we need that much time, and then we'll go over the answers.
Do we get our book for that? The big book?
For right now, no, but I'm gonna just go ahead and make you guys. I'll have them like this, so you can just copy them down. I will send the email, so in case you want to print them out.
Okay. I already have the book. So.
Oh my God, yes, Jessica, go. All right, let's try. Does anyone need some more time? If you need time, just give me a vertical hand and I will. Okay, I have 1. Okay, that's fine. All right, let's go over question number 3. Do I have a volunteer that wants to see if they got it correct for number 3? Herman?
Number 3 is 6.4 times 10, 3.
Yes. 6.4 times 10 cubed, you could say cubed, or 10 to the third power. Yes, I'll accept that. Awesome. Great job, Herman. Great. Number 4, Rolly, I see that you want to, come out of the screen, but you can't. What is number 4?
It is 5.7 times 10 to the power of 11.
I like it. Absolutely.
like it.
5.7 times 10 to the 11 power. And then number 5, Julio, go ahead.
9,461,000 to the power 10 times 10 to the power of 12.
Yes, great job. 9.461 times 10 to the 12th power. And since we are using a unit here, we're using kilometers. If you want, you can add the unit there just to keep everyone a little bit happier. All right. Who got all 3 of those correct? Give me a thumbs or a hand. I should see all hands because these are super easy. Awesome. Okay. So now we're going to do another your turn on page 35. If you have the pages, number 35, you're going to do 8, 9, and 10. So for this one, you're going from scientific to standard. Don't forget commas. There we go. And I'll give you about 2-3 minutes. Go ahead, guys. All right, guys. Does anyone need some more time for these 3 problems? Okay, awesome. I'll give you a little.
Oh, I'm sorry. I didn't know I was sending them to the public. I thought I was sending it through private chat.
All right, let's do number 8. Alex, since you went ahead and shared the answer with everybody, Can you tell us that number?
It's 7 million.
Nope.
300. No, I mean 7,034,000,000.
That's it. Yes, there's no units. Yes, awesome. Yes. So 7,034,000,000. There you go. That one's a pretty cool number to say. I like it. 34 billion, 34, 7,034,000,000. Pretty cool. Number 9. Let's see. Let me try someone who hasn't said anything. Dwayne, number 9.
Man, pick Kayla.
I already picked Dwayne. Dwayne, what is number 9?
I put 23,600,000.
Not quite, buddy. Kayla, number 9. Help out Dwayne.
236,000.
There it is. 236,000 for number 9. I think you might have put one too many spaces, I think, Dwayne. Just double check that one.
I put one more zero.
Yeah, just make sure you double check those. All right. And number 10, we're going to find the roosting colony of monarch butterflies, what their mass weight is, I guess. Let's see. Chelsea, number 10.
5 million.
Awesome, 5 million. And since we have weight, right, we're gonna put grams just to keep it a little bit more consistent. We'll put the weight, just put the letter G. G is the, how you put grams is just letter G. All right, any questions on these 3 your turn problems that we did? No,
It's
pretty
very
easy.
ma'am.
Awesome, great. All right, so we're gonna take our 3-minute stretching break. So go ahead and please turn off your cameras, go walk around, and I'll see you guys in 3 minutes.
Rolando, your camera. Rolando, your camera is on.
Yo, your mic.
Hey, Leo, what do you,
Julio.
Leo,
What?
Leo, what do you do? Like, what do you do here?
You're supposed to go out and play games, or as the teacher said, just go outside.
Yeah, but like, why do you always stay behind?
Who doesn't? I'm just on my tablet right now playing games.
Oh,
Me too, I'm watching YouTube.
nice.
It sounds like you're watching Henry Stickmin.
Someone was doing that. I do not know who, but someone was.